So happy summer. Happy Thursday. I hope everybody's doing well. Hope everybody's got I could say a start to the summer season, but it seems like, I don't know, maybe it's me. I feel like summer's almost over because it goes by fast. I can't believe it's July already. But anyway, my name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. Thanks for being on today, where we're going to take a look at the additive manufacturing extension for Creo. So leading the webinar today is going to be Paul Dye. He's a solutions consultant and applications engineer with PTC's Virtual Center of Excellence. Paul normally does our webinars on a monthly basis, weekly basis, because we run these kind of frequently. We've slowed down in the summer. And Paul is very insightful, always does a great job. If you have any questions, please type those into the Q&A. We'll try to answer them as we go along, but we'll definitely answer them at the end of the webinar. So Paul, you have control and lead us, my friend.
All right, sounds good. You can hear me okay and see my screen?
Hear you good, see your screen. We're ready to rock.
Awesome. So thanks, Rob, again for having me on. And thank you, everybody, for joining as well. So again, my name is Paul Dye, and excited to go through and talk a little bit about how we do additive manufacturing in Creo. It's definitely something that I find myself talking to a lot more people about more often than not nowadays, something that we've put a lot of time and effort and research and really just investment into what we do from an additive manufacturing perspective in Creo. And I'm going to be going through a couple of different areas. I'm going to talk about just some of the challenges we typically see whenever it comes to manufacturing in general. I'm going to go through our solutions in terms of additive, walk through a couple of examples of what that looks like in the context of Creo. And throughout this, if you have any questions, feel free to drop those in. And without further ado, go ahead and start into it just by talking about some of the challenges we typically see really just around design in general, right? And if you've done design for any stretch of time, you realize that a lot of the decisions that you end up making from a design perspective tend to be driven simply by the manufacturing methods that you plan on using, because things like injection molding or milling, they have certain considerations that you have to take into account. And it really limits you in terms of the types of geometry that you're able to create. A lot of designs just simply aren't possible to create using certain techniques or manufacturing methods. It can also be very costly and require a lot of long lead times to even create the tooling that you need to manufacture products. There's a lot that goes in the equipment to begin the manufacturing process in many cases. And as the parts that you work with increase in complexity, so do the costs, so do the lead times, things that we see time and time again. And most times we end up seeing people either over-engineering or making things overly simplified just because it would be too difficult, too time-intensive, or just too complex to optimize the part, but still be able to manufacture the model correctly. So it means that there's a lot of things that we'd like to improve upon, but just due to those types of limitations doesn't really become reasonable. So what we found is that additive manufacturing can provide the solution to a lot of these different challenges. Like I mentioned, we've put a lot of time, effort, research into Creo, specifically in our additive manufacturing extensions to give you the functionality that you really need to start building your designs with this new world of capabilities in mind. And one thing I like to really harp on is the fact that I see additive manufacturing being different than what you typically think of as just 3D printing or rapid prototyping, right? It's not just a means of prototyping in the process before you go through and use standard techniques to manufacture your designs, right? We can really use additive for full-scale production parts. And a lot of it goes into the design itself. And that starts with our standard additive manufacturing extension. One of the biggest areas that we've had a focus on in this extension is the idea of creating lattices. I'll go through and show what this looks like in the demonstration, but lattice structures in general give you the ability to create some very strong, robust geometry, but at the same time, you're able to save on material costs, or in a lot of cases, you're able to make the design more visually appealing, while at the same time making it as strong as possible. And lattices in general have been something that simply wouldn't be able to be created using standard manufacturing techniques, right? It's not something that a 3-axis mill could go through and create, but for an additive manufacturing piece of equipment, a 3D printer, it's a piece of cake, right? Not only to automate and design in Creo, but also to create out on a 3D printer. And you'll see that there's many different types and configurations that you can use. essentially with every single release of Creo that we have, we're adding to the types of lattices that you can work with, adding to the parameters and dimensions and capabilities that go into each of those lattices as well. So at the end of the day, take out a lot of weight and still be structurally sound. And one thing to mention around that as well is that it's integrated in seamlessly with any of our other applications, optimization, analysis tools that we have in Creo. So it allows you to not only build out lattice structures and optimize your models specifically for 3D printing, but also go through and optimize them from a number of different considerations or constraints that you want to work with. And the idea is that you're moving away from over-engineering designs just to simply get them to work. Instead, we can build them out how we need to and not have to worry about whether or not they're going to be manufacturable or not at the end of the day. And again, once you've gone through and optimized the structure of the model, you can take it into any of our analysis tools to see the stresses, deformation, temperatures. These can all be directly integrated into that process as well. So really working towards a much better design overall with that too. And then right from within Creo, we're able to do printer tray optimization. We're able to do it manually. You can build out patterns, however you want to go through and have those parts arranged in the tray. We also have the ability to do what's called nesting optimization, where the system's able to go through and optimize the placement of the parts that you have in the tray to give you the best possible orientation whenever it's time to print those parts out. And then once they're built out, they're just saved as a standard Creo assembly file that you can work with later on as well. One thing that you also get as part of the standard additive manufacturing extension is a 3MF file. This is a big upgrade from what you would typically think of whenever you're working in 3D printing, where normally you'd just be using an STL. You get access now to a 3MF file that allows you to include much more into that file itself. You can include different types of material settings, different types of orientations, or different types of even appearance settings in there as well. So everything that you'd want to send out ultimately to the printer, you can have that included in that 3MF file itself. So a lot of people that work with the additive manufacturing extension are simply looking just to get access into that 3MF file. But from this point here, we also have an option for additive manufacturing advanced capabilities. So really the idea here, first and foremost, is that we're going to be playing a little bit more into metal 3D printing. But what it starts with first and foremost is printer connectivity into the build process that we work with through one of our partners, Materialize. It's the iMagix build processor. It really is the foundation for the large majority of metal 3D printers that you're going to see out in the industry. So we can connect directly from Creo into those printers. We have the ability to manage them, add new ones in, look at the jobs being sent to each one. You don't have to go into a separate slicer even to do that. You can just do that right from within Creo. You also have the ability to very quickly go through, define and build out tray configurations and taking capabilities that are specific to metal 3D printing. And that includes the automatic generation of things like your support structures. A lot of times whenever you're building out support structures for metal printing, there's a lot of different considerations that you have to take into account. So we give you a lot of different configurations and settings that you can go through and build out for those support structures. It focus on things like easy removal, heat dissipation, material savings, and all those things are going to be very important in the process and really all things that we can build into that printer setup as well. And so with that, I can go ahead and show what some of these different tools and capabilities look like from within the context of Creo. If you have any questions throughout that, feel free to drop that in as well. But let's go ahead and jump here into our Creo environment. And I'm going to be working with a data set that we have from one of our customers, Royal Enfield. This is one of their motorcycle assemblies that I've worked with a lot of times in the past. So I'm going to go ahead and up here and start to walk through some of our different additive manufacturing capabilities. So from my perspective, there's a couple areas that I want to work on here. So we'll start first and foremost down here at the muffler and the exhaust assembly. I had the casing here. I can go ahead and grab one of these internal parts that I want to work with. So this piece here is the start of the sound attenuation in the muffler. And you can see the current design is fairly simple in this case. It may have come from a previous past design. And the idea is probably that it's very straightforward to manufacture. If you take a look at the section view, it's essentially just a couple holes going through a straight cylinder. So that's the existing system and really the start of our exhaust control. But maybe we want to get to something different. We want to improve on this. Maybe now we have a 3D printer on site, or maybe you're even working with a third party in order to do this, to try out some new designs. So I'll start first and foremost by clearing out the center area and I want to use our latticing capability to see what I can come up with. This is just simply available up in the engineering tab, and these can range from very simple to very complex, but the idea is that the 3D printer has no problem creating this type of geometry. So it's just going to start as a lattice feature here in Creo. And the first thing that we'll do is define the lattice region, which will essentially be a boundary or area that the lattice will exist from within. And once you have that, you'll select the cell type that you want to use. We can start off just by trying a stochastic lattice. This is going to give us more of a randomized ball and beam structure throughout here. But the idea is with any of these, regardless what cell type it is, you have a lot of options and different parameters they're able to go through and change and work with and move around. You change the cell size, the nodes, the diameters, cross sections, change those around until you're happy with the structure. And once you have that set, you're able to visualize what that would look like in the part and see if you like what you got there. If you do, you can go ahead and accept that and start to prepare for 3D printing. Or if you don't like it, or maybe you just want to try out a couple of different things, you could go right ahead and do that as well. So let's take a step back here and try more of a 2.5D shape if you want to simplify things a little bit further here as well. And even with these, you have a ton of different options for the cell size, the shape, options for exactly how that lattice is being created. And you can zoom in here if you'd like to and change more about this. If you wanted to make that wall thickness a little bit thicker, do that. Maybe you want to go through and round off the inside radius a bit. Simply lay that out in the options, and you're always going to get an instant preview of what that's going to look like on an individual cell level. And at any point, again, I can tell the system to show me what it's going to look like overall after it's created. And even after we save that off, you're still able to go through, work with it, analyze it from that point. Another one that I can go through and show you here is our formula-driven lattices. This has been a big area of research that we've done and continue to add upon from within Creo. It's a little bit more specific to your metal 3D printing, but the idea with these lattices is that they have fully self-supporting geometries. There's no need to build out complex structures and supports in order to be able to print these. And really, in general, it's completely changing the rules for what something like this muffler center section could be here, right? It's able to look a little bit more like this. Right, so definitely a little bit different from what we were working with earlier, right? With just those couple of holes going through a straight cylinder. And if you like what you have here, you can go ahead and accept that. And once you do that, it gets built out as a lattice feature. All right, so again, that's something that's only able to be manufactured with additive. It's done by taking advantage of all the different enhancements that we've had in the world of additive, and really a ton of different lattice structures that we can go through and build out here. It's definitely something that you're going to want to check out and see all the different options that we have in terms of latticing. So that's the first main capability that we're going to work with. More so on the design side is building out those lattice features. And what I can move on to now is into the process of printing the actual parts. So we'll go ahead here towards the front end of the assembly. This might be another part that we're planning to print the outer case here for one of our sub-assemblies. And taking a look at the part here, it's actually a fairly complex piece. Normally it would require a lot of work to cast and then maybe machine all the different features or holes, or even machine everything from a stock piece of material. So what I'm going to do instead, first and foremost, is use additive manufacturing to create the main shape for this, right? So what this is going to do for us first and foremost is allow us to work with some materials that might not do very well with something like a casting, but whenever it comes to 3D printing, we have no problems whatsoever. So what you're looking at here is essentially what it would be first and foremost before you would go through and maybe machine off some of these finer edges. And we see a lot of people doing this nowadays where they're using 3D printing to print out the main shape of what you're working with in terms of the model. And then from that point, you'd put it over onto a machining tool, maybe a 3-axis or a 5-axis mill to go through and do some of the very precise edges that you want to get extremely low level detail around. So that's what you're seeing here is essentially I'm rolling back some of the features that later on we might go through and machine off, right? So that's just using some different flexible modeling capabilities there to do that. But again, we're just going to go through and work with the model that we're planning on 3D printing here. Right, so first thing I'll do is start into a build tray and a build direction for the print. I'm going to use a plane that'll really act as the base for the build tray. It's where we're going to begin the plane from, or begin the print from. Once I have that, what I will need to figure out is how I want to position the piece of the tray. Because again, if I'm trying to save on things like scrap or material waste, definitely want to cut back on the amount of support material that I'm generating with that. So the best way that we have of doing that here in Creo and the additive manufacturing extensions is using a build direction analysis. So first thing that study is going to look at is critical and subcritical angles. Anything that would go beyond those angles is going to require the use of support material. You can see that we have that highlighted here on the model and any red or yellow spots for that. And then from this point, instead of us having to go through and try out different positions or manually determine the best orientation, we can just simply let Creo do that computation for us in that build direction analysis. And it's able to take into account different percentages that we can set for what we want it to focus on. We can have it focus more on material savings, or maybe we want the model to print out as fast as possible. We can go through and lay all that out, and then Creo will go through and iterate, try different things out, and figure out what that optimal position would be to allow us to focus in on the different goals that we set for it. Right? There might be some parts that you work with where the optimal print direction might be pretty obvious. If it's more of a boxy shape, could be fairly straightforward. But whenever you're working with real life models, whenever you're working with a piece like this, where it's a little bit more round, a little bit more complexity, might not be as obvious to figure out. So we can let Creo do that for us. And then it's going to give us an orientation that we probably wouldn't have thought of on our own, but it's going to be optimized for the part that we're working with. So you can see there, it's just going to be a coordinate system that we can use to print whenever we set up everything for our particular printer. So that's what I can do now is go through what that process would look like for preparing that part and laying it out on our printer tray. And again, this would be the real printer tray that you have out on the shop floor. You see Creo can be linked up into a lot of these different types of printers, where we can send our prints directly from Creo to get printed. We support direct interfaces with plastic printers through 3D systems. Also metal printers that use the iMagics from Materialize, that build processor. Again, covers a very large majority of the metal 3D printers that you're likely going to come across. And once you have that specific tray and build tray set up, we can go ahead and arrange our part onto the tray. So that's again, whenever we can use that build direction that Creo went through and optimized for us over in the build direction study. And with that build direction assigned, we now have the ability to determine how the supports are going to be generated. So this can take into account things like earlier where we're looking at the self-supporting angle, a lot of other properties that we can go through and change. But one thing that we're able to do here is generate those support structures right from within Creo. Right? It's not even something that you have to ship over into a different program or a slicer. You have the ability to stay right here from within that same interface. And one of the nice things about that is the part changes, the printer settings change, it's all able to be associated, right? We can update the support structures without any hassle, visualize what those supports would look like. But maybe in this case, that was done with a pretty low self-supporting angle. In this case, maybe our printer requires a self-supporting angle of 45. Well, what we could do is switch between different support structure profiles if we'd like to. It's very easy to go through and switch between those. You now have a different angle, maybe some different parameters that we're working with here. And with that angle switch, we can go ahead and generate the supports that we have. So that's the idea. You can have a template set up for one printer, have different settings set up for another printer. You can see with this one, with that higher self-supporting angle, it's going to require a little bit more support material. All right, so from that point, what I'm able to do is take that part. I can take the support structures. We can preview and visualize the slice file right here from within Creo as well. That would just be a CLI file that we can generate and either share off or just view right here from within the same interface. And what Creo will do is generate however many slices it takes to create that design. And once it finishes going through each of those different slices, we have the ability to display each and every slice that goes into creating that design. Let's go ahead and get a little bit better view here, switch to a top-down orientation. And what that allows us to do now is view what we have going on here. We can spot check this, make sure that we understand and approve of every single slice of that's actually going into the part that's being printed. If there's any geometry that you want to change, you can easily go back and make changes to what you need to. And that's really one of the biggest things to notice throughout every step that we've taken in this entire process, is that it's right inside of the same interface, right? Whether it's for building out your lattices, starting from maybe a fairly standard, simple part, be able to do your preparation for 3D printing, do it all right from within Creo, right? You start with the base model, optimize the build direction to cut down on the use of support material. You can set up and connect your model into your particular printers, generate and edit the supports, the slice file, really everything that you need from that 3D printing process, you can just do right here from within Creo as well. So whether or not you're doing this for plastics or using a metal 3D printer, we have these different additive manufacturing extensions to really take you step by step through that process and ultimately make sure that you're sending out the best models to your printers. So with that, that really covers everything that I wanted to go through and show. Again, if you have any questions, feel free to drop that in here. And while you'll be doing that, I just want to take a brief moment just to really cover some of the main benefits that this really gives you, right? And it covers a lot of different areas. First thing is reduce time to market. With this, you're able to go through and cut out a lot of the process that would typically be required to get your parts from your design software to manufacturing. But again, you're able to do this in the same environment. You do everything from within the context of Creo. You're able to get into production that much faster. You're able to do more product introduction, right? You're able to try a lot of designs much faster through that. You're able to try out a lot of designs that maybe you only would have thought of in the past. But again, very easy to go through and build out in the context of Creo. And you're not only making high quality products, but you're able to innovate throughout the entire process as well, right? You don't have to worry whether or not something's able to be milled or casted or anything like that, right? You just try different designs out to your heart's content. And at the same time, you're able to reduce a lot of the costs that go into manufacturing. So these are all things that we've seen people time and time again getting as benefits from additive manufacturing in Creo. And hopefully I was able to go through and show you a little bit about what that would look like. So that really covers everything that I wanted to talk to today. And I can pass it over to you, Rob, to wrap up from there.
Paul, great stuff as always, man. Appreciate it. So the recording is going to be sent out tomorrow at the latest. So we'll go out to everyone who was on today, as well as people who registered, because sometimes things come up. You can't make a webinar, but you got the recording, and that always helps. So next week, I'm gonna have an invitation go out tomorrow to next week's webinar, which is going to discuss collaboration with SolidWorks and Inventor, utilizing Creo's Unite technology. This is something that's in the base license of Creo. And what's interesting is sometimes, from talking with our customers, a lot of times, we're busy. Like, we're busy at 3HTI. You guys are busy at your companies. And we use different technologies too. And sometimes we don't take the time to pick our head up and, really learn some of these technologies. I mean, it's something that we're doing recently because we're like, yeah, we need to know more about this solution that we're using, the software that we're using. But a lot of times we're so busy, we don't take the time to just learn it. And a lot of people don't realize some of the basic functionalities within the base license of Creo. So every now and then we'll have a webinar showcasing those capabilities, like design exploration extension. And next Thursday, we will be discussing Unite technology that is within Creo. So we look forward to seeing you then. So once again, Paul, thank you very much for a great overview and presentation. And I want to thank our audience for being on. Have a great week, rest of your weekend, everybody. Take care.